In this lesson, we are going to look at how a measurement can relate to another measurement. Now, before we do that, let's look at the definition of a measurement. Just a review, a measurement, like any measurement, it must have a number and a unit of measurement, and sometimes it would have the chemical, okay, or the substance that go along with it. So what about the number? The number could be anything. It could be any number, right? And of course, followed by the unit. And of course, the unit could be any unit. And what are some of the common units that we know? Like, for example, we have gram represented by letter G, or we have milligram represented by mg, or we can have liters, okay, or we can have meters, or we can have milliliters. All of those are units. And what about followed by the chemical? And this is usually written in a chemical formula. So what are some of the chemicals that we have? For example, we have carbon, that's the carbon element, or we can have water. There are endless variation of chemicals that we can work with. So keep that in mind, okay? Or sometimes we can just have carbon dioxide, that's a common one, or oxygen. There you go, a little bit more for chemical. Now, what is the term that we use to describe the relationship between two different measurements? The term is called a conversion factor. A conversion factor relates, okay? Think of the term relationship. What does relationship mean? Well, in mathematical terms, when you relate one thing to another, they are equivalent to each other. That means they are equal to each other. So keep that in mind, okay? And that's how they are related. So relate two different measurements. Notice how I use the term different measurements that have the same values. Wait a minute, how can two different measurements have the same values? Isn't that impossible? Well, if we look at the unit carefully, and we look at the number carefully, or even the chemical carefully, let's look at something very basic. We have $1, okay, and that's equal to 100 pennies. Notice how these are two different measurements, right? And how do you know? First of all, the number is completely different. But in most cases, this is where it's tricky, is that the unit right there is different. Because the unit also have a values to it. Like, for instance, 1 penny is a lot less than $1, okay? So because the unit are different, now you have the opportunity of having two different measurements that are equivalent, or in this case, they are equal to each other. Another common one is 1 foot equal to how many inches? 12 inches, right? There you go. So those are the possibilities of having two different measurements that are equal to each other. Now, of course, in reality, there are endless of conversion factors, but this allows us to understand that there is measurement, or there are measurements that are equivalent to each other, and that's how we have the term conversion factor. Now, the beautiful thing about conversion factor is that it can be written as a ratio. Now, think of math term. A ratio can be written as a fraction, right? And of course, a number on top and a number on the bottom. So that's a fraction. And that's only possible when we write a fraction. And when we have a fraction, that is only possible when the two numbers are equivalent to each other. So keep that in mind. Are they related together? So in this case, there are two equivalent measurements. Let's look at one example. So let's look at this example. We have $1 written as a ratio equal to 100 penny. Notice how they are equal values. When you have two numbers that are the same on top and bottom into a fraction, like, let's look at number 2 divided by 2. What do you get? Of course, 1. How about 5 divided by 5? Notice how the values are the same? It's equal to 1. So in this case, because they are the same values, they are equal to 1. And why is that important? Because now we can actually write 100 pennies equal to $1. So we can actually manipulate the location of the unit. because they are the same values, and simplify equal to 1. Or let's look at this one where we have 1 foot equal to 12 inch, and that can be simplified equal to 1, right? So in this case we can have 12 inch on top equal to 1 foot on the bottom. Isn't that beautiful? Now let's look at the task for this activity. Determine the possible conversion factor or factors from the given set of statements or statements. Well, in this case, let's look at this one. There are 100 pennies in a dollar. Notice how we have 100 pennies in a dollar. When you see the article A, that represented as 1. So 100 penny. And notice how penny is written in plural form, but when we write a conversion factor, we try to keep everything singular. So that way, there are less letters that we have to focus on. And it's equal to $1. Isn't that easy? Let's try another one. We have 1,000 milliliter equal to 1 liter. Oh, that's even easier. That is even easier. 1 ml equal to 1. Oh, notice how this is liter, right? Can we abbreviate liter? Of course, it is a letter L, so we put 1L. Because we want to simplify our math. We don't want to write too many letters because it's going to make us confused later on, okay? And then here we have 1 moles of carbon. The unit, of course, is mole. Now, carbon, can we abbreviate carbon? Yes, it's represented by the letter C. And we has 12 grams of carbon. Gram, what letter we use to represent grams? G. And carbon represented by C. So 1 mole, there are no abbreviation for mole. Actually, the abbreviation is MOL. But what's the point of doing that? Let's just put MOLE. So that equals 1 moles of carbon. Well, so we have 1 moles of carbon equal to 12 grams of carbon. Isn't that nice? Easy, okay? And let's try another one. At any temperature, 1 moles of H2O has 6.023 times 10 to the 23rd molecules of water, or H2O. So we can ignore that. Now we just write this. 1 mole of H2O equal to has, okay? When you see the word has, that means it's equivalent to. In this case, 6.023 times 10 to the 23rd molecules of H2O. Oh, this could be singular form. Again, my mistakes. There you go. Let's try another one. At 0 Celsius and 1 atmosphere pressure, we have 1 moles of carbon dioxide gas has, of course, that's the equal sign, 22.4 liter of gaseous CO2. So we have 1 mole CO2 equal to, notice we can shorten this to L, and 22.4 liter of CO2. Isn't that easy? Last one. 1 moles of water has 2 moles of hydrogen. So this is already abbreviated already. Hydrogen can be H. So we have 1 mole of H2O equal to 2 moles of H. And that's all we have to do. Just make sure when you type on a computer, make sure you type them together, do not space, okay? And that's all we have to do in terms of define a measurement and how different measurements are related in terms of conversion factors.